So let us now focus on each section of the nephron and look into it a little bit more detail. Firstly, focusing on reabsorption. Let's look at what happens in the proximal convoluted tubule and the ascending limb of the loop of Henle. The lumen here refers to tubule of the nephron, so inside the nephron tube. And the cells here refer to the cells which line up the tube of the nephron. And here is the vasa recta, which is a circulation. In the proximal convoluted tubule, sodium reabsorption occurs together with glucose or amino acids. We do have to mention that the glucose and amino acids will get reabsorbed back into the circulation. There is another transporter which works like exchanger sodium to hydrogen ion. The sodium is reabsorbed inside the cell and then is exchanged with potassium, both against their concentration gradient. This is the sodium-potassium ATPase pump. The sodium-potassium ATPase pump is very important, and it is situated usually on the basal aspect of the cell. The proximal convoluted tubule is important in regulating acid-base balance. This is the area where the hydrogen can be secreted. It's also the place where bicarbonate can be reabsorbed. Here it is necessary to mention that a chemical reaction takes place. Hydrogen ions inside of the lumen of the nephron react with bicarbonate ions to create carbonic acid. Through the carbonic anhydrase or carbonate dehydratase that catalyzes the interconversion between carbon dioxide and water and dissociated ions of carbonic acid. Water is also present inside the cell. Carbon dioxide is a gas which can diffuse back into the cell. So carbon dioxide can diffuse back into circulation. Furthermore, within the cell, the same reaction can take place with the same enzyme, carbonate dehydratase, which makes carbonic acid again. Carbonic acid can then become hydrogen ions and bicarbonate, and the circle can continue. And that is why when you have an increase in carbon dioxide levels, you are more acidic because the shift from more hydrogen ion production and causes more acidity. The hydrogen here can also come from circulation. The bicarbonate can be reabsorbed into the circulation to increase the pH of blood to make it more alkaline if it has to. And it does with a symporter, a type of transporter which brings back sodium and bicarbonate into the circulation. And so the bicarbonate reabsorption in the proximal convoluted tubule is sodium dependent. It is important to notice that other electrolytes also reabsorbed in the proximal tubule, which I haven't actually drawn, and these include calcium ions. The ascending limb of the loop of Henle is an area where electrolytes are also reabsorbed. There is a trisymporter, which is another transporter, which brings in 1 potassium, 2 chloride, and 1 sodium back inside the cell. The potassium and chloride then go through another symporter, which carries them back into the circulation. While the sodium gets exchanged for potassium through again with the sodium-potassium ATPase. Important to note here, on the apical surface on the top of the Henle cells, there are passive transporter channels which allow to sodium to enter into the cell from the lumen and also potassium to enter to the lumen from the cell.